Hey, today we're going to talk about this paper that I wrote a few years ago. It's called In Search of the Graph of Knowledge, and I made an intro video to it about a year ago, but I didn't end up doing anything else on it. So I feel like now is the proper time to conclude the idea. And I'm going to attempt to make this as quick and painless as possible. I know that people like fast videos, they want to get their information as quickly as possible. This is an educational video. I make educational videos. This isn't, but the difference is that this is original information. This is from my head. Like, this isn't a regurgitation of material. A lot of people are very successful with presenting little packaged videos about information that you can find yourself, and just this is not or that's not a characteristic of my videos. Again, this is a paper that I wrote. It's called In Search of the Graph of Knowledge. It's what I do initially is I start out trying to quantify knowledge as opposed to looking at it qualitatively, because depending on what situation you're in, you would want to know one thing as opposed to another. So that would be a concern, a qualitative concern. But for quantifying knowledge, we start out thinking about cavemen, basically, and how the knowledge of how to construct a hand axe requires things like knowledge of rocks and hardness, where to find rocks, where to find the right type of rocks, knowledge of how to bash the rocks together, proper technique, and many different things that they go into. And it becomes apparent very quickly that it's difficult to quantify knowledge. Otherwise, somebody would have already done this, and it would be common knowledge. But what I find is that it's theoretically it could be quantified if you got extremely specific with it. But the best generalization is to just say that knowledge is nested. So there's it's just like with mathematics. It builds on itself. Well, knowledge builds on itself. It's nested. Even simple things like, learning to walk. I mean, we have these we have instincts, which I believe is like an inherent type of knowledge that we have already when we're born. And then we look at comparing knowledge. Obviously knowledge of how to build a hand axe doesn't have as much potential weight as knowledge of how to build an atomic bomb. But in the time of hand axes, the bow and arrow was like the atomic bomb then, whereas in our time it was like from guns to ballistic missiles, and then atomic, or right about the same time we had ballistic missiles and atomic weapons. But a lot came out of World War II, as I'm sure you're well aware of. But moving on, my paper was basically in the context of the futuristic idea that is fairly well presented in this book by Ray Kurzweil called The Singularity is Near. It came out like 10 years ago, 2005. Singularity is Near, Ray Kurzweil. And it's just, my theory, or my idea in this case, isn't really necessarily based off of his. It's just his book is a good starting point to go off of. And in his book, he, on page let's see, I think it's like page 90. Yeah, page 70. He has the exponential growth of computing. And I think I'm going to have to add in some slides to this video. But I guess this will just be like the front end of it. It's an impromptu presentation. But with knowledge being theoretically graphable against time, so you got time going along and knowledge is increasing. But since knowledge is nested, it's very hard to quantify. We're not really going to be able to get a solid, concrete graph, but we can sort of generalize. We can say that knowledge is increasing. Okay, but how is it increasing? What is the basic shape of the graph? And that's what the paper's really about, because I read The Singularity is Near and realized that he was wrong about, he's right, but he's right about what's happening, but he's wrong about how fast it's going to occur. And because what you have to do, like the main mistake that people make in thinking that our growth is just going to continue exponentially is that assumes that there's an infinite number of things to be learned, like an infinite amount of complexity to the universe. And if we're looking for a theory of everything, obviously it's going to be a finite equation that explains everything, or set of equations. And one of the first things that you have to realize is that there's a zero and a maximum. There's a zero knowledge and a 100% knowledge. There's a 100, like a total amount of things that theoretically could be learned. And what's striking about my idea is that it predicts knowledge will not, or our growth, computing speed. It's got the paradigm shifts. Paradigms go back from, because he has a logarithmic plot for, the first thing is like fire and the wheel, language, and modern civilization, and everything just gets closer and closer together, and it appears like everything is going to continue to get close, that the paradigms are going to continue to get closer and closer together. But I believe that's a false positive. A false positive. And
what's actually happening is that we're approaching an inflection point, and I searched for a couple of days until I found the right function that is a better model than f of x equals e to the x. This is the general, people throw out the word exponential a lot of times, not even realizing that that's like referring to an exponent, like a number raised to a power.
It just grows really quickly. But the logistic function, and this is, all rights reserved. Like what I'm saying right here, like the application of the logistic function to looking at trying to map knowledge over time. It's my idea, so don't steal it. But what happens is, you have f of x is equal to 1 over, in parentheses, 1 plus e to the minus x, and that gives you an S-curve that ranges between 0 and 1. Remember I said, knowledge between 0% and 100%? It's going to be a better model, assuming that there's a finite number of key, useful information to be learned. We're not talking about just, knowledge of where a leaf fell. I mean, eventually we'll get to a point where we're going to be able to trace back every physical event. At least I believe that. But we're just talking about key knowledge in terms of scientific principles, etc. And so you get a false positive prior to the inflection point. That's where the graph stops increasing and then begins to decrease. And we're still below that point, so it looks like we're going to continue to just take off like an airplane, just. But there's there's nothing to continue to take off into. At a certain point, it starts to curve back off. And a lot of people are going to be disappointed, I believe, if they don't take heed and notice of my idea. Because it's a warning, it's a forecast. The logistic function applied to knowledge over time is a warning to slow down. So I'm going to talk about the logistic map, which is the discrete analog to the continuous logistic function, which neither touches the x-axis or touches. It has 0 as a limit at negative infinity, and it has 1 as a limit at positive infinity, which should begin to suggest to you that you'd have to go to infinity or somehow breach infinity to even get to 100% knowledge. But before we get to chaos, the chaos that's inherent in the logistic map, I'll give you the main analogy that I use for the graph of knowledge. It's the Easter egg analogy. And the Easter egg analogy goes like this. So you say it's Easter and there's kids and they're waiting to go do the Easter egg hunt, and we're the parents, we put out 100 eggs. That symbolizes all the knowledge bits that are available, and then we hide them prior to the search. The kids are in the house, we hide the eggs, and then we release them from inside, and they run outside and they start picking up eggs, putting them in their baskets. Well, if you put the egg hunt, the total egg hunt from no eggs found to all the eggs found into bins, you make a hexagram, it's going to be the case that in that first bin they didn't find any because they were walking out to get to the field where the eggs were. It symbolizes evolution, it's it's over a very large scale, but the analogy covers evolution over millions of years. And but if you just bend the time out, and then we're gonna find the most obvious eggs first. Those first few eggs that they find, are the initial paradigms that define early human development, like the cave art, the ability to express things symbolically, fire and the wheel and all that, like, and you hexagram it out, and it's going to have a bell curve, like a bell-shaped distribution, basically, because once you get to they're getting better and better at it, and they're like, oh, this is fun, we're finding more and more eggs. But then you hit that halfway point. That's the inflection in the logistic curve. Because if you take the derivative of the logistic function, which the inflection point is at y equals 1/2, but the maximum point of the derivative of the logistic function is at y equals 1/4. So that would basically translate to, whenever we have found 1/4, or that would just be the rate, like that. In other words, like the fastest rate that we could get to would be 1/4. But don't think too far into it. And so then you realize that there's more eggs to be found, but they're harder to find. Because they were more well hidden. And they just, each bin you would find fewer and fewer until you're finding the very last few eggs that are most well hidden. You see the analogy? Because, like, the golden egg is almost always the last egg to be found. It's the most well hidden, and yet it's the most important one of all. In Christianity, it has like a Christian symbolism there, but that's not what we're going for in this case. It's just, we could make it go that way, but you can just keep it more like scientific, analytical. It's like, it would basically indicate that, we got so full of ourselves, and we're finding all this information out, and then we find that the graph is logistic and not exponential, and we're like, well, shit, it's getting like harder and harder to figure stuff out. Why is this happening? And then we find like the 100th egg, like the golden egg, and it's like the most sublime piece of information of all, and it just like dwarfs everything else that we had previously uncovered and held up to be in such high regards, and yet again we could not have gotten to that, finding the golden egg, without finding the other previous 99. So but then with so I feel like that's a very powerful analogy there. And so the logistic map, if I have time here, it's f of x sub n plus 1 is equal to a constant k times f sub x to the n times 1 minus f x sub n. So the function, like each time you have x sub n that gives you your output, your f of x to the n sub 1, or x subscript n plus 1, then you turn around and you plug that back in, and you just do it. You just keep doing it over and over again, and it's like a very simple equation, but it ends up uncovering chaos theory, essentially. I mean, you can look into it on Wikipedia and other places, but I guess that's pretty much it. wrap up this video. I hope you enjoyed it. I hope you subscribe to my channel. I don't make any money doing this, and I want to be able to continue doing this like full time. I'm looking at lecturing here locally and wanting to branch out from there, but I'm a bit discouraged at this point, but I'm trying to stay positive, and every like, every subscription, every comment, like negative or positive, is just like motivation for me to keep going. And if you watch this whole video, then you can, at this point, you would realize that I do have like an original way of thinking, and I have many more ideas to offer you. I'm working my way up to the best ideas that I've ever had. I feel that's the most logical way of doing it. I mean, I know people like to say that we should, school is taught in such a slow and drawn out way, but we should teach it the other way around. I mean, whether that's the case or not, I'm holding off on the most important, the most profound things that I've realized, and you should stick around for them, because it's new information. It's educational. Even if I'm wrong, you're getting mental stimulation, and that's all there is to it. Thank you, and we'll see you later. Okay, sorry everybody, but since this was an impromptu video, and I'm not the best at keeping my ideas in a good order where everything that needs to be said gets said, I have to add in this bit of information that I've kind of, that I left out. So there's 3 things here that I left out. The first one is that there's, with the logistic function, it has the x-axis as a horizontal asymptote. Now, what that suggests is that, in the same way that 1 is the horizontal maximum asymptote, 0 is the minimum. And if we're thinking about evolution and the evolution of, or the regression of the universe from the Big Bang, it would seem to suggest some non-zero positive y for knowledge, even at the Big Bang singularity there. And so it's in line with all of these new theories of consciousness as an emergent process. So we look at it and we're like, oh, well, if you're one of those people who's uncomfortable with something coming out of nothing, I mean, I'm not, as I understand it, like from a more like mathematical perspective, very quickly, like 0 is the sum of all real numbers. So, there's people like Nassim Haramein who are very big and like hot on the trail of like this idea that there's like infinite energy in the vacuum, which is supposed to be empty. So it's a little bit of a side note, but if you think about something coming from nothing as like just a contradiction right off the bat, then you will like this idea, because it's just basically saying that there had to be some fundamental knowledge in the fabric of the universe that just grows like a flower. So there's like a seed of knowledge in everything, a little fundamental I am at like the quantum level. I call it automatic consciousness, and it has an inherent analogy in it that it's just basically that it's like Horton Hears a Who, the Dr. Seuss book that they made into a movie. You know, the elephant, he had the big ears, and he was the one who was able to hear the tiny little people on the speck of dust. And it's related to the the brain in a vat in philosophy, where it's a brain and it's alive. It's like a person and they're alive, but you don't know that they're alive. And you take someone off this street, or say like we take our caveman, because he's not going to know what a brain is, and we're like, hey, you see that object inside of that other object, which is like a glass container with fluid in it keeping the person alive. They're not going to recognize that as a person's brain necessarily, and it's going to be very hard for them to realize that like that's a thinking thing, like that's a person, and that it's like a human being's brain in there that's thinking. And another analogy that we have in it is the passenger analogy. So it's like if you're in the back of a bus, like rewind your life back to whenever you were a kid and you were riding the school bus. You're not the driver, but you're thinking and you're looking out the window and you see the world going by. But if you get in a wreck, God forbid, or the school bus driver like turns left or turns right or goes straight or speeds up or slows down or stops, you don't have any control over that, and yet you are sort of like you're a passive participant there. And that's kind of how we can think of automatic consciousness. So that at the quantum level, there's like a very like scaled down, like several dozens of levels of like orders of magnitude at which you're going to have consciousness in everything, but it's just passive, like it can't do anything. It's that brain in the vat. It's got its arms and legs chopped off. It can't do anything, but eventually they all get together and they're able to like stack up and do this video. So that's the first thing that I kind of forgot to talk about. The second thing that I forgot to talk about was to explicitly state that Ray Kurzweil's idea of the singularity being near is, in my method, the inflection point is near. So the singularity is the inflection point. That's the big upset, Things continue to increase. No, that's the inflection point at which the growth curve starts to taper off. And I think you got that out of the first explanation that I got. So that was just one thing that I forgot to explicitly mention. And then now talk a little bit more about the logistic map. It's a good fit for knowledge, because knowledge and the gain in knowledge, like you didn't know you were going to click on this video, and if you got anything out of it, then you wouldn't have been able to predict what you were going to get out of it before you clicked on the video. So that's just like a little micro picture of how knowledge and the gains, the growths, the insights that people have, it's very unpredictable. And that's what the logistic map is. First of all, the logistic map was initially used to map the growth of bacteria, or maybe that was the logistic function, which is that's the continuous version, which you have the discrete and the continuous versions. But the discrete one is cool because it's in line with the idea that knowledge is quantifiable. So if it was quantifiable, then it wouldn't be continuous. It would be like it would be like little tiny steps. So in that smooth S-curve on the logistic function, it's actually it's made up of little tiny S-curves that are like oscillating. But the further along you get the more unpredictable it becomes. But there is a plateau, like there's several little plateaus that you can reach, which I believe indicate in a very general sort of way that these higher beings that are visiting our planet, I believe they are, I mean, I've seen UFOs, and I haven't made any videos about my UFO encounters, but I plan on doing that very soon. But you just imagine that there's advanced entities visiting us. There's a prediction from the application of the logistic map onto knowledge versus time that shows that there are some semi-stable plateaus around in between like 65 to 75% of the total amount of knowledge that can be gained that are stable enough to where, you know, an advanced civilization can just reach a plateau and not have to grow any further from there. Like they reach a really high level of development where they have like immortality and wormhole technology, and they just because it's so hard to get any farther beyond that you settle for an extremely high level of development. And nothing wrong with that. I mean, we're probably several millions of years away from that, if hopefully only thousands or hundreds of thousands of years away. But it's again, it's not the Kurzweil vision of we're gonna wake up in 20 years and all of a sudden like every day is like the reinvention of the wheel. It's not going to happen. Go back to the Easter egg analogy. Think about that some more, and you'll understand. Yes, those are the things that I forgot to mention. And once again, thank you so much for watching, and I hope you have a good day, and come back and see me later.